So welcome everyone. This is the session on teaching using blended learning approaches. My name is Katie Vale. I'm Director of Digital Learning at the Harvard School of Public Health. And it's my pleasure to introduce what we've done, a real sort of all-star cast today. And we'll be talking to you about different versions or different applications of the blended approach. Now, I did want to just sort of say a little bit about sort of what is blended learning, because there sometimes is some confusion about what exactly is not blended. So the most general definition of blended learning is some combination of sort of traditional sort of in-class teaching methods with work that students complete online and at their own pace. So sometimes blended learning can be at the entire sort of program level, where students are sort of physically on campus for a while, then they go off back to wherever they come from and do work there. And since my boss is in the audience, I'm going to put in a plug for our new Master's in Public Health degree, which is going to be Harvard's first such blended program, where students will be on campus for some part of their work and doing the rest of their work in an online capacity. But today what we're really going to focus on are blended approaches for the on-campus program. So we have three faculty who are going to talk about, or faculty teams who are going to talk about using blended approaches in teaching on-campus students. And then we'll also hear from an expert in educational assessment who has been looking at recent attempts at using the blended approach in a variety of Harvard courses. So first up we have my colleagues from the School of Public Health, Pamela, Rist, and Adam Sullivan, and they are going to talk about a course that they just taught this past summer.
So I'm Pamela Rist, and this is Adam Sullivan, and we're going to talk to you today about an example of how we used blended learning in our course this summer. So first, we just wanted to give you a little bit of background on how our course was set up. So our course was called The Principles of Biostatistics in Epidemiology, and this was a summer course at the School of Public Health that fulfilled the school-wide requirement for epidemiology and biostatistics. And what made our course unique was that we actually integrated material from both disciplines. Usually kids take one core course in epidemiology and one core course in biostatistics, and they're completely separate. But they actually work closely together in real life, so we wanted to show the students how the two disciplines are complementary and also collaborative. Just to give you an idea of our class size, we had about 15 students who were in the newly launched Doctorate of Public Health program, and these students had a pretty wide range of backgrounds. Some had worked as epidemiologists, while others had no prior coursework in either epidemiology or biostatistics. So it was important for them to be able to work through the material at the pace that they needed based on their background. So our course had two main components, an online component and an in-person component. And the online component was primarily composed of weekly videos. And we actually used the videos that were developed for a prior Harvard X course called Public Health and Numbers. That was taught by Dr. Marcello Pagano and Dr. Fran Cook, both professors at the School of Public Health. And Adam and I assigned the students to watch particular videos from this course prior to our in-person sessions. Some students we found didn't actually like watching videos, so we also did have written materials. And these were some notes from the Harvard X course and also a biostatistics textbook. So the students could use either format depending upon what they were comfortable with, but the main goal was to come to class prepared. You watched the videos and you read the textbook to learn some of the theories and definitions and derivations of the concepts we applied in class. So for our in-person component, we had 2 4-hour in-person sessions per week, so a pretty good amount of class time. And they were designed to reinforce material from the online component. So the videos might teach you a definition, but in class we actually wanted you to apply that definition to a real scenario. So we did things like article critiques and problem sets. We also had them develop and collect data and then analyze data for a semester-long research project. And usually how class time went was that sometimes Adam or I would work through a problem, and then other times we would split the students up into small groups and let them work on their own. So for today, we wanted to give you an example of how this would work. So we're going to have you watch a short video and then work through quickly one of our exercises on contingency tables. And we chose contingency tables because they're the point at which epidemiology and biostatistics really come together. So for those of you that might not have seen one before, a contingency table basically tells how many people were exposed, and of those people, how many did get the disease and how many did not. Of the unexposed people, how many did get the disease and how many did not. So previously in class, we had already gone through study designs. How do you study the association between an exposure and a disease? We also talked about how you construct contingency tables. And we told them how you use the data in those tables to calculate measures of disease frequency. How common is this disease? And also measures of association. How much more likely am I to get the disease if I'm exposed compared to if I'm not? And what we wanted to do in this exercise is actually teach them how to analyze the data and determine if there's a statistically significant increase in your risk of disease. And how you do that is through a chi-square test, which I'm sure many of you know. So what we're going to have you do is we're going to have you watch a section of a video that Marcello Pagano recorded. And in this, he's considering whether electronic fetal monitoring has an impact on cesarean decision. And he goes through some of the derivation and theory behind the chi-square test. And then Adam will talk you through the exercise that we followed this video up with in class that week.
Now, how does this chi-square test work? Well, exactly like all our hypothesis testing works. Namely, you start off with the if. If the null hypothesis is true, if there's no difference between those who were EFM exposed and those who were not, that's our null hypothesis, what do we expect to see? Then, what did we see? And then compare the two. Compare what we saw to what we expected to see. So what do you expect to see and what have we seen? And so we'll have to come up with a statistic that compares these two differences and then consider how this statistic varies from sample to sample to sample. So the same approach as we've always taken in this. So for example, let's go back to our numbers and we display them in our little 2x2 table. So there's the little 2x2 table. That's our null hypothesis. We say that the C-section rate is unaffected by EFM exposure. Now, if that is true, then we can ignore the column classification and just go with the totals. So we can say, okay, what is the CFM exposure? Well, we've got 587 out of the 5,824, so roughly 10%. So this is how we're going to be arguing that if we ignore the EFM exposure, this is roughly 10%, 587 over 580. So we expect that same 10% of these, we expect that this should be 10% of those, and of those, this should be 10%. So let's just play with the numbers instead of the bar graphs. And so from the totals, we can estimate what is the probability of a C-section. Remember we said that's a roughly 10%, so that means the probability of no C-section is 0.899. So let's apply this probability of a C-section to each of the two groups, those who had the EFM and those who did not. So what do we expect to see if EFM has no effect? Well, then we'd expect that of the EFM exposed mothers, all 2,850 of them, roughly 10% should have a C-section. So we expect 0.101 times the 2850, so that's 287. So we expect that 287 of these mothers would have had a C-section. And that means that roughly 90% of them, 2850, which gives us 2563, would have had a vaginal delivery. This is if the 10% held for these mothers, the EFM exposed. And this 10% we got from everybody, which was ignoring the EFM exposure. Okay, so that's the way we proceed. Okay, so here we are. We've now calculated what we expect to see. Now, it's a little bit different than when we had the mean and we expect the sample mean to be close to the population mean, and then we looked at the difference, say, between x bar and mu, and to test our hypothesis, and we said, okay, to really understand this, we need to divide by some sort of measure of the standard error, and then we compared that to whatever it was, minus 1.96 plus 1.96, depending. Here, this difference between what we expect, this is what we expect, and what we've actually observed, turns out to have 4 components. We've got 4 cells. So that makes it a little bit more complicated than just a single number that measured the distance, how far away we were from the null hypothesis, if this was hypothesized mean. So how do we do that? Well, let's look at this. What we could do is look at this difference, and then look at this difference, and then look at this difference, and then look at this difference. Now, unfortunately, the same thing happens here as happens with when we introduce the standard deviation. We can't just look at those differences and average them out, because they would always sum to 0. So, once again, we can square them. So look at the squared differences. Okay, that makes sense. And then we can sum those up and look at what happens there. But it's not quite satisfactory, because look at this cell here. This cell and this cell, they're roughly at 300 or so. 200, 300, something like that. Whereas these are at 2,000, 3,000. So they're 10 times as big. So a difference of 10 here, let's say, in this cell, is not the same as a difference of 10 in that cell. So we need to normalize. And so how we're going to normalize is the trick. And that is how we develop this statistic. It's called the x squared statistic. It's going to take the sum over all the cells of the observed minus the expected squared, so that they don't sum up to 0, divided by the expected. There it is. This thing is called the chi-squared goodness of fit test. This is the x-squared statistic that gets compared to a chi-squared distribution, and just as with the t, we need degrees of freedom, and degrees of freedom are calculated as the number of rows minus 1 times the number of columns minus 1. In this case it was a 2 by 2 table, so it's 2
so that is a little bit of what the students would be watching in the notes. We did cut that down a bit. Marcello tends to go into a lot of the history behind things, where things developed from. So a lot of his notes can get a little bit long, so we cut that one down to be able to display for today. So when the students are at home, they're expected to watch those videos. In between the videos are short questionnaires. They're not graded. It does tell them if they're right or wrong. If they're wrong, they can go back and look through the videos. We also provided something like manuscripts to the videos. It took a lot of the text in it and put the tables and the charts and stuff to show the students if they preferred reading. But once they got into class is when we started different activities. So for this particular day, the students read a draft of a manuscript of a study, and it was looking at the association between chocolate consumption and cognition. So what we first had them do is critique the article. And throughout the semester, we've been teaching them how to critique articles, how to look at their statistics section, how to look at their study design. Did they pick the proper study design? Are they really answering the questions that they set out to answer in their abstract or in their introduction? And so we had them start out with that. And then we looked at the information provided in their results and had the students actually construct the contingency tables and wanted to see, can you match the actual data analysis that they did in this paper? Does it match what you find when you run a chi-square test on this? So in the interest of time, we're just going to give you the information rather than having you go through the paper. So Again, the study aim was to investigate possible health effects of daily consumption of dark chocolate. The outcome of interest was cognitive ability at the end of the academic year, which was measured using the Wonderlic personality test. And among a sample of 70 HSPH students, 28 were the exposed group. They ate dark chocolate at least once a week. Of the exposed, 23 had above average cognition ability scores. Of the 42 unexposed students, 26 had above average scores. This, of course, is all made up data. We did not actually get this. Fran Cook wrote this up as one of the teaching examples, and so we've modified it and use it with the students as well. So the goal is to construct a contingency table off of these data. So with this contingency table, we have what information was presented to us was above average scores, or above or below average scores, and then we know if they were exposed or if they were unexposed. So the information we had on the previous slide was that of the exposed group, 23 of them had above average scores, so we would fill in this with the 23. Of the unexposed, 26 of them had above average scores. We also instructed the students to also fill in the other information they had. For example, we know that there were 28 exposed and that there were 42 unexposed. And from just those numbers, the students can go ahead and do the subtractions, and they achieve this table. The next step of this would be calculating the expected counts. It can be very confusing to try to look at the numbers on the table and say whether the cells are different. We have to take them in context, so we calculate the expected values of each cell. So when we go to calculate those, we first ask them about the chi-square test, like what are the null and alternative hypotheses for this? We would usually wait a long time if they didn't answer because we are not giving this one to them. We've done enough of these prior to this. So the null hypothesis should be that there's no association between eating that dark chocolate and an above average test score on that Wonderlic test. And the alternative would be that there is some sort of difference or association. Sorry, there is some sort of association. So we create that table of expected counts. We created the same way that Marcello talked about in the video. What he did, he mentioned the notion behind how we calculate them. Essentially, in practice, what they do is they just take the row total times the column total divided by the total number in the table. His explanation of the video is good for them to get a sense of why it's done that way, for why we use a proportion, not considering who's been exposed or unexposed. And then the next thing would be actually performing the test. So we'd ask them for the value and distribution. What is the p-value? And then do we fail or reject the null hypothesis? Okay. So this would be the value of the test statistic. So we'd have a 3.28. And that'd be on chi-square 1 degree of freedom. And so it'd be a p-value of 0.07. So in most cases, they would fail to reject the null hypothesis and say there's no difference. Okay. So a little bit about some of the things we learned. We did learn that the online components and the in-person complemented each other. Videos and reading materials provided some of the theory behind what we wanted to do in class. But the in-class was actually how we reinforced and then sometimes actually taught them how to do the material. With these online materials, we actually have a lot more class time to actually spend on problems. Rather than only getting to see problems in a TA-run lab, we were able to run and do group work and do a lot more extensive problems with the students. And this opportunity provided a lot of benefit for them. And they really appreciated actually getting to see and work together through these problems.
Well, we'll have a little bit of time for questions for each person, but then we'll hopefully at the end have a few minutes where everyone can join in. But I did sort of have one question just to sort of prime the pump is, what's it feel like to use materials that somebody else created? Is it?
So we've talked about this. I kind of have the unusual scenario that Fran Cook taught me Intro to Epi. So it's not as unusual. We did actually change the order of some of the videos and did supplement some of the lectures with things in class. So Fran doesn't have a lecture on a topic called causal inference, which has now become very popular in epidemiology. So we did do some of our own, and also we did edit some of the videos if there were particular things that we knew they either didn't need to know or that we wanted to cover in class instead.
And I mean, I work very closely with Marcello. He's one of my advisors on my dissertation. But Marcello really views his videos as a video textbook. He's wanted to bring his biostatistics textbook from, I think, 1992 and bring it into more modern light, update some of the examples, provide cohesive examples from the Framingham study throughout it so students get used to using that one major data set. So these videos were his way of basically revamping his textbook to be able to reach out to new people. So from my experience, we assigned them expecting that they would do it like a textbook, and so all of our classes were designed with the thought that a lot of them might not have actually done their pre-work before coming to class.
So Peter, why don't you come and start getting set up, and we'll take one more question.
I wanted to ask if you could clarify a bit how you ran the class time during the in-class segment when they did that example. Were they working individually? Were they working in small groups? How much time did they spend working on the problem that they had done the pre-work for?
So for this particular class, it was 4 hours. So we actually did another type of contingency table. We did a brief review, another type of contingency table first, which I actually walked them through because there wasn't a great example of that in the videos. And then for the paper, we actually split them up into small groups. They probably spent about 30 to 45 minutes reading through the paper, critiquing it, and then also trying to do some of the problems themselves. They had a list of the analyses we were going to ask them to do. And then we came back as a big group, talked about the paper, and then worked through the problems. Because some groups instantly realized how you program these things in Stata, versus other groups needed to be stepped through it a little bit more, just because of the range of students.
And you were sort of walking around.
Yeah, we walked around the whole time. So it's
We were
only
able to guide
15.
these
Yeah.
groups that weren't as comfortable using Stata or took a little longer. We were able to work with them, guide them through it. And then the other groups were able to just go through it and ask questions if they needed.
Yeah. So even in class, they could pace themselves based on their background.
How long are the videos?
It depends. So some weeks some videos are 3 minutes long, some videos are 13 minutes long. We tried to keep them all under 15. We did have a schedule for them so that they'd know how many hours of video prior to each class. And that was something that they really requested just so that they could plan out their week. The heavy weeks had about 3.5 to 4 hours worth of video for a class. That was at the very beginning when there was a lot of material you need to get through. Later on in the semester, when their group project ramped up, they're maybe doing 1.5 to 2 hours.
Well, thanks, Pamela and Adam. So Pamela has to race back to Longwood to teach a class, but Adam's going to stay around so that he can answer additional questions sort of at the end of the session. But it's now my pleasure to introduce Peter Galison. He is the Pellegrino University Professor in the History of Science and Physics, and he's also the director of the collection of historical scientific instruments in the Science Center, which if you've never gone to visit is definitely something worth doing. So without any further ado, I'll let Peter tell you about his work in hybrid Einstein.
So I started as thinking about what to do with the recording of a course in a very conventional way. I had my course, students wanted to have my course streamed, and I felt increasingly like a Luddite not letting them do that, even though I knew that that would probably increase the number of students who didn't come to class. In the Science Center, our courses have about a 50 to 60% attendance, which is pretty typical across most big courses at most universities. In fact, it's not a bad outcome in the sense of comparison to other places, but it's not a great way of using your time when half the students aren't there. And I think it's important to remember this because when we think about this experimental moment in the classroom, And not everything works, and I think we need to face that this is a transition, and we're really learning, all of us, I certainly am, about what works and what doesn't. It's great. Jenny is going to speak later, Jenny Bergeron, about her assessments about these courses, and what I've learned from her, what I can see with my own eyes. There's some things that work and some don't. I'll show you a bunch of things. And some of them work, some of them don't. But it's always, as the jazz song says, compared to what? And it's compared to 50% not going to class. So when students say they don't like getting up at the crack of noon and coming to class, you just have to keep that in mind. So my experience is with a course called the Einstein Revolution, which I've taught in various forms for a while. I keep changing it. But it's a course that uses Einstein not biographically, but as a thread through the 20th or the long 20th century to the present, late 19th to the present, divided into relativity, the relativity theories, quantum theory, and nuclear weapons, but using that as a way of getting at the cultural response and sources of the physics material through art and science relations, through the philosophy of space-time and causality, through history, through warfare, and so on. We live in a mobile, asynchronous, interactive time for students, but also for all of us. We're used to being able to access information when we want it, to be able to divide tasks over time, and it's a struggle to try to make the older formats work for people who are used to getting their information in other ways. I think I'm not a declinist. I think our students are as fantastic as they've ever been, maybe more fantastic. So I don't agree with the many published articles that talk about the decline and fall of the modern student, and wouldn't it be great if they were all like 1990 or 1970 or 1950 or whatever the person writing the article's own time was. But then the question is, instead of just filming the course, I thought I actually work, half my time I'd say is working as a documentary filmmaker, and we could do a lot better than film taken by a sleepy undergraduate, lying down with his coffee spilling on top of the laptop, from shooting from 50 feet back with a bad camera, out of focus, off screen. So what would it look like, and what could we use? My first thought was just to make it look better. And then I thought, well, once we start filming, we can do all these other things. We don't have to stay in the classroom. We can have conversations with people that are not going to come to our class once or twice a year for the next 5 years. We can use media in a different way. We can make animation. We can do the kinds of things that I do all the time, making film. So, but then that precipitated the second question. Once you start to do this, what do you use the classroom for? So there are two parts of this, and it sort of tumbled for me from what started, like most tasks and mission creep, with just making the footage look better so that you could actually read what was on the screen or on the blackboard, to using a more filmic representation, to experimental ways of using the camera, to other forms of media, and then to really reassessing what the classroom might be like. So that's what I want to talk a little bit about today. Here's an example of a conversation with a colleague, Hilary Shute, at the University of Chicago, about a graphic novel that had by Keiji Nakazawa, who is a great graphic novel.
And we have these, I think, very moving scenes of everyday family life. So here's a scene of the family having dinner. We learn that there isn't a lot of food in the household. Here we have a scene of Keiji visiting his father as his father is working and asking him to please teach him how to draw a soldier. We get a sense of the kind of rhythms of their everyday life. He says here, my happiest times were catching grasshoppers, right? So we get a sense of the slowness of their life in addition to the big events that they were dealing with, like the war. Then the book takes us to 8:15 a.m. And what we get here is a panel that is actually representing the explosion.
This is August 7th, 1945.
Right. Here in small letters, it says 8:15 a.m. Many of the survivors described their experience of the bomb as a noiseless flash. People's faces are starting to be framed in only black and white. We have a sort of expressionistic view of a purple tree flying through the air, broken apart, and then the panel goes all black. There hadn't been imagery like this in any other drawn work.
So, this is something that would be hard to do in an ordinary lecture because you're talking about small representations on a comic book, and you can use the kind of graphics moves that you can use in film, using media, namely comic books, that really had a profound effect on Japanese self-awareness as to what had happened. In America, since the late 1940s, we've been using John Hersey's Hiroshima, but that was written from somebody from the outside, after the fact, interviewing people. This was by somebody who was there at Hiroshima as a child and who lost a big part of his family, and is one of the great graphic novelists of our time. Another example of something that I could do is with
one of the great
animation.
Consequences of Einstein's thinking about relativity was that simultaneity was not the same for a rest frame and a moving frame. Two events that are simultaneous in a rest frame are seen to be not simultaneous for a moving observer. Imagine a train station. Lightning strikes at 2 points equidistant for an observer on the station platform, and the flashes arrive in front of her nose at the same moment. Unambiguous, they started equidistantly, they arrived at the same moment, they are simultaneous. Now those two strikes occur as events in space-time. You could say, are the events in the station or on the train? No, that's not the right way of thinking of it. They're just flashes, they're just points in space-time. The way if I took a tiny pencil mark on the street, that's not in one coordinate system or another. You can assign it different coordinates depending on how you organize your coordinate system. Well, so it is in space-time. There are two flashes that occur in space-time, two events. Now, imagine a train roaring through the station, some goodly fraction of the speed of light, really good train. An engine driver and a caboose driver are equidistant from the middle conductor. That's what it means to be a middle conductor. You're between your front and the back of your train. We imagine that those original lightning strikes occur gently in front of the nose of the engineer and in front of the nose of the caboose driver. But do those flashes arrive at the train middleman's nose at the same time? They do not. Why? They do not arrive simultaneously at the middleman's nose because as the flashes are radiating backward from the front engineer's flash, the middleman is racing towards where that flash occurred. So the flash has less far to go and gets to the middleman's nose first. Conversely, the middleman is racing away from the place in space-time where the caboose driver's flash occurred, and so that takes a longer time to get to the middleman. So what does the middleman conclude? He knows he's the same distance from the engineer than he is from the caboose driver, and he gets those signals at different times, first from the engine and second from the caboose. So he concludes as night follows day that the flash must have been issued first from the engineer and second from the caboose driver. Two events that are simultaneous in the station occur at different times in the moving frame of reference, one then the other. Crucial in our reasoning is that we're...
So that's the kind of thing you can do with pretty simple animation. This isn't, complicated 3D simulations here, but it helped a lot. Then I tried some things that were just a little more sillier, but Einstein wrote a little play about himself arguing with an anti-relativist based on a play of Galileo, The Dialogue of Two World Systems, I'm sure. So I played both parts, and here's the
I'm Criticus, kind of amalgam of Einstein's nemesis. a bit of Friedrich Adler, a bit of Philipp Lenard, one of Einstein's most ardent critics and later a Nazi whom we'll meet in the further part of the course. People like me have often expressed their criticism of relativity in journals, but rarely have one of you relativists actually shown up to respond. Maybe it's out of a feeling of weakness, maybe it's arrogance, maybe it's laziness, maybe it's a toxic brew of all three. Or maybe it's that the critic has shown by what he says that he didn't know what he was talking about. But right now, I will not leave until you've answered all of my questions. I am not, like some of my colleagues, so steeped in the great...
This had the advantage of, since I have a bad memory for when I did theater in school, I drove my teachers crazy because I'd say, well, this isn't exactly what Macbeth said, but it's a very good paraphrase. So that satisfied the Harvard lawyers, and I didn't have to get permission to use this material. Now, assessing things online, you could use multiple choice questions. They work very well for the physics. Elementary science and engineering were born to be treated by multiple choice questions, not advanced science and mathematics, where it works terribly, and not for the humanities, where it's equally terrible. There are collective exercises where you have commentary on texts, films, group constructions of wikis, debates, and there actually are ways of creating this online, and I've used that a fair amount. And mini essays, which are crucial, I think, for understanding the humanistic part of this course. So I've been working on these in various ways. At first, edX was saying that they could make an AI, an automatic essay evaluator, but that was airware. It didn't exist. It never will exist. But peer review peer assessment by students of other students can work. I mean, obviously, our graduate students and we faculty are not going to grade 75,000 essays a week. So we need some way of having peer evaluation. And I don't care so much about the grading part. That's, that can be normalized. You can get a pretty good grade by having rubrics to be examined and then averaging them and so on. But it's really the feedback. That is crucial. So the students need to write essays and they need to get feedback to learn. And that I care about passionately. Whether they get a B+ or an A-, not so much. Now, that may become important in the future, and I'm sure if we want to assign grades and cell degrees and so on, that's going to be very important. But right now, that's not my concern. So multiple choice questions, you might have it, which you explain a geodesic is the shortest line between 2 points, and then they have to evaluate that, and then based on if they get a wrong answer, there are other questions that can follow up. Sometimes there'll be collective debates where I will group people together into teams and they'll have to argue. So this is one of the collective debates. The year is 1943. You're approached by one of your physics professors who says he needs to speak with you about a top secret project. The Nazis, he says, are working on a nuclear weapon. Will you participate? Press A to join the wiki debate team arguing yes. Press B to argue no. And then each side prepares a brief, and then they're exposed to the other, and then there's a response, and so on. And I had online discussions. So I've only taught this as a hybrid course. It'll go online in an open way in January. They'll create wikis. This is on a particular device that we talk about in the course. There's a famous montage by Hannah Höch from 1919, and Einstein figures prominently, the main face in the image, the face of modernity in a sense, cutting into Weimar culture. And they had to identify the different parts of this and then collectively figure out how to understand what this was. So those are examples of collective activities. So that's a kind of spectrum of things that I'm looking at in the course. There are also demonstrations of physics experiments and things like that. But what do you do in class? So the question then for me is, what can you use class for? I mean, you can clean up things that they haven't understood properly from the online. But what's unique? What's special about the class? And we start by saying, what can you do with a camera, basically? and really push it as far as it can go. And then the question is, what can you do in a physical class that might not be accessible? Well, one thing we can do here is we have one of the great scientific instrument collections, which Katie mentioned, the collection of historical scientific instruments that began its collection by Benjamin Franklin back in the time of the Revolution. And I divided the class into 6 tables, which I very frequently did for various sort of jigsaw puzzle-like activities. And each one got a different object. And then they went down and they studied this object in the museum. This is an atomic clock, for example. This is a chronograph, basically a fancy clock that's used on ships, because knowing the time difference between where you are and what it is in London, for instance, would allow you to figure out how east or west you are of London, with the determination of longitude. And I could have them use these objects in depth, and I had them take their cameras and go in and photograph details of these things that they wanted to comment on. So that each table had to do some research. What is a chronograph? How are they used? And then comment on the material aspect of this thing, something that you can do more or less with pictures on the web, and all of our instruments, all 20,000 of them are on the web, but to really get in and look at them and sometimes be able to open them with the curator present, of course, and look at the way they're built, what materials are they using, why are they using those materials, or, to tell from that whether it's a demonstration device or a luxury device or a working device. Those sorts of things are crucial. And another example of something you could do in class was I have pairs of plays and transcripts, like the Oppenheimer hearings from April 1954, and a play written about the Oppenheimer hearings, or the play by Michael Frayn called Copenhagen, about a meeting between Bohr and Heisenberg in 1941, and the transcript of the captured Nazi scientists from August of 1945. So you have these exchanges from the tapes, like this, between 3 of the captured scientists. Hartek says, if we'd worked on an even larger scale, this is right after they've been told that the Hiroshima bomb has exploded. If we had worked on an even larger scale, we would have been killed by the Secret Service. Let's be glad that we are still alive. Let us celebrate this evening in that spirit. Diebner, who's a gung-ho Nazi. Professor Gerlach would be sitting in Luxembourg as a war criminal. Wirtz. If one hasn't got the courage to mount a major effort to build the atomic bomb, for the Germans, he says, it is better to give up straight away. And they really went at it. And so these tapes were blocked by various families of the German scientists for decades, but they came out some years ago. And so now I had the students divided into groups, one reading sections from the play and one reading sections from the transcript. I had them read them with different emphases, with different interpretive, so even if you have the actual transcript about what historical actors said at a given moment, there's still a lot of interpretive play that's possible depending on how you read it. Do you read it sarcastically? Do you read it literally? Do you read it with emphasis? Do you read it with sadness? And I had people from the ART come in and talk to us, and we did play readings with them. And so that's a kind of thing which you just, well, I wouldn't say you can always do things with other media, but it's much better. It uses physical presence, the presence of collections, of a great theater group of students here, and so on, to be able to do something. So, bottom line, what I think now, having taught the course, had the students watched all, interacted, all the videos are organized into lessons, 16 lessons. Each lesson of about an hour of playtime is divided into 4 parts. They're typically an individual set of multiple choice questions about the science, a collective activity of the type I mentioned, and a mini essay. So that's a typical organization. It's not true of every lesson, and I think of them as lessons, not lectures. And they could be modularized, and I expect that they'll be used different pieces for different courses, a little bit like the way you guys were using it, because I don't think of these as sort of plug-and-play objects. I think of them as that they have to stay as a whole, that they can be used more piecemeal. And then once we've got these sorts of things, then we can use the classroom to be different. And I think that really, in some ways, is even more radical than the online, because the online material is great and exciting and difficult and very challenging, who the audience is for this and how we're going to work that. But then to say we're going to really reassess what we mean by a classroom in the 21st century, that's really dramatic. And I'll stop there.
While Sarah's getting set up, we can take one or two questions quickly here.
Yes.
I have a very fundamental question. Your animation of the trains?
Yes.
How did you animate that?
So, you know, when you have just a simple linear object like this, there are programs that will interpolate the motion, so you can, it's actually not that time consuming to make.
Can they sync with sound?
Yeah, I mean, there's sync sound in there. I mean, like the lightning crashes, for instance. I mean, it's not complicated by the standards of animation. This is incredibly simple. Most of the image is not moving at all. The train moves as a block. The lightning strikes. You know, it's a couple of elements. This might be maybe 7 hours of work to do that one, and I'm working with somebody who's really technically adept at this, and then there's the reciprocal one where you take the view of the train, not the station, and so I mean I did a bunch of these through the course.
Well, therein becomes the question, because you said it took 7 hours to make that example, and one of the frustrations I find in trying to adapt this stuff is getting the technical support to. We can't possibly make all of these ourselves.
No, I mean it depends.
And so
I don't
my
know.
question is, how have you navigated that in working with edX?
Well, I had some money from HILT, and one of the things I did was to get an editor to work with me on these, and you know I hired somebody who I knew had some basic animation skills, and then I designed what I wanted the animation to do, and he's able to put it online. I mean, my particular experience, I started when all these, Harvard's involvement with edX was really just starting. And so I had to do a lot of stuff in my little team of a couple of graduate students and editor. So it's more efficient now. And I mean, there's the studio in the basement of Widener, which is quite sophisticated and very competent people there. But at the beginning, there wasn't so much help. But you know, to make, you know, how in any part of the technical side of things, you should always ask yourself, or ask the people who work in that area, if you haven't done filmmaking, are there small changes that would make a big difference in the effort? Right. So, for instance, having one moving object against a fixed background is much simpler than having 2 or 3 things moving. So, and 2 dimensions is much simpler than 3 dimensions, and you know. So, but for everything's like that. It's not complicated, for instance, to do the doubling yourself. That's a kind of pretty easy trick. I filmed against a green screen, but I need to turn over. Sorry. So. You know, you do need help to make one of these, and I use some of my own equipment at the beginning, my own camera, and so on. But yeah.
She was first. Okay. Just conceptually speaking, do you know what you want to do before you do these films and clips, or do you let the process of putting together films from, let's say, that exist there with your own animations guide a kind of process to that eventually tells you what you will do with the material?
I mostly I tried a bunch of different things that didn't work at the beginning. I wasn't using a green screen. I found that gives you a flexibility later that's much more helpful. I didn't know what audience I was speaking to exactly. Was I talking to Harvard students? Was I talking to a high school student from Outer Mongolia? Was I talking to a retired air and space engineer from Lockheed Martin in California? You know, I mean, and you have to get straight who you're what your audience is. I think that's one of the most important things. and you have to figure out, I tried reading scripts, which didn't work for me, and I tried total improv, which didn't work. So I then had a structured set of, a very structured outline, and I knew pretty much what I wanted. Then after I'd finished them, I've gone back and I've said, I want each lesson to have a variety of different visual registers, so it's not just me talking for long periods of time, which I found tedious. And so then I would sometimes look to do that. But you have to have, you can waste an awful lot of time if you don't have a pretty good plan. At least I could.
Thank you, Peter. We'll try to have some time at the end for questions, and I hope you all will be joining us for lunch, where our panelists will be able to speak further with you. So now I'd like to introduce Sara Suchman. Sara is a recent doctoral graduate from the Graduate School of Education, and she's going to talk about a HILT-funded project that she worked on with Professor Merseth, who was actually teaching at this time. He's not able to be here. But Sara's going to tell you about their project on creating materials for blended learning that they call learning bundles.
Thank you. Kay says hello. I'm sorry she can't be here. And I'm going to talk about the learning bundles that we created. And I'm going to talk a lot about how everything that we did was pedagogically driven. This didn't start out as a technology project. It didn't start out as a blended learning project. It started out because we had a pedagogical challenge that we wanted to address. That said, we could not have done the work we did if it weren't for the learning technologies team over at the Ed School. And so every step of the way, they helped us design it and think about it. And so we are really quite indebted to them. It would not be the same without that. So here's the pedagogical challenge, is how do we address really challenging, controversial dilemmas in our classrooms, or with our students, not in our classrooms. And this comes from the feeling that the world is full of really complex things that are going on that need to be discussed. And too often, most professors, many professors, the students come, they're ready, and they hear the professor's point of view. And even if the professor includes other readings on the syllabus, they tend to be the counter-narrative to be rebutted rather than viewed on an equal footing. So that was our pedagogical challenges. How do we bring really good discussions about these issues that people come to places like Harvard to discuss to the students? And so we've created learning bundles. We wanted people with differing views to address the same issue in a thoughtful way, and we hoped in a way that we could reuse multiple times. So readings don't quite hit it because readings aren't answering the exact same question. They'll talk around, but they're not being asked the exact same question, the two different authors. Debates tend not to be thoughtful. They tend to be one-off. Who's the better debater? And guest lecturers or guest speakers are a logistical nightmare, expensive, and not reusable. You can film it, but the students' questions aren't the same questions that your students might have asked the speaker, and so they're not quite the same as being there for the live thing. So what we decided to do, or what Kay's thought was we're going to interview and videotape experts with opposing views around controversial dilemmas, edit those videotapes, and package them and create a bundle. That's what it was, videotaped interviews. That's where we started. What we ended up creating, we learned, were reusable, multimodal, modular learning assets. That's all the words around it, and here's what they are. We've got video content production, which is a lot of work, and I'll get to that later, but we would make video content production, supporting readings. We would house these two things. These two things are housed on currently the iSite, but they could be on another platform if the university moves away from iSites. We've created, through using them, figured out sort of teaching steps, a methodology, kind of like the case method, the bundle method, that you can apply regardless of what the controversial issue is. The same steps that a teacher can go through, and then assessment. These are what we've done so far. We did, our first bundle was on race-conscious admissions in higher education. Second one was, and we're all both at the Ed School, so they are education topics to date. Bundle 2 is the role of the charter school movement in publicly funded American education. And Bundle 3, which has been made but not piloted yet, is multiple languages in U.S. schools, how to serve all students. The first two bundles we have shown to over 400 participants. Over 400 people have participated in one way, in one setting or another, in one of these two bundles. And the next one, so these two we've done, we've taught a lot of, we've taught them in class, we've taught them to evening sessions, we've taught them online, and I'll get to that. This one will be piloted in the spring, and right now we are talking with people over at the Data Center for Eurasian Studies. They have, as part of their federal grant, they have a K-16 outreach obligation. And they're talking to us about creating a bundle that they could put on their website that people throughout the country could access and use, which would also include our needing to put on that website how to teach with one of these bundles. So that's another thought, is that we've got these teaching steps. Can we teach how to teach it this way? And can we let go of the control that that means and what comes out of that when other people are doing it instead of us? So the first one, when we did the race-conscious admissions, it was just your basic face-to-face lesson. We did it, it stood alone. We did it during January term. It was advertised as just an evening session during January term, 2 hours. Come if you're interested. We watched the videotapes of the interviews in class. We had the clickers. We took people's opinions after each videotape. We had the discussion, totally self-contained, face-to-face. And we've done that. We did it in January. We've done it for student groups. Clubs have asked us to come and do this one. And we've done it with faculty and staff at Teaching and Learning Week over at the Ed School. So all different settings. And it works well. Lively discussion. Everybody participates in the surveys and the feedback and the assessment. And you can gather data at all different points. And 90% of the participants over all these trials have said that they feel that the combination of the videos with the discussion is stronger than either would have been alone. But you lose a lot of class time and a lot of discussion time watching the videos. And just like I think I've heard in both of the prior presentations, what do students most want to get out of class time? So and what they most want to get out of class time is they want more time to discuss it. So how do we do that? And we thought, okay, so we'll have them watch the videos at home. It's flipped, but it's not that different from a reading. They're watching the videos at home instead of doing the readings at home. So to get more class time and time, we decided we'd take the multimodal, taking the distance challenge. So we had multimedia, we had videos, we had class discussion. We had multi-use. You could use it in different settings, you could reuse it. But now how are we going to make it multimodal? So we've done the face-to-face, and now we're going to try flipping it. We watch the videos at home, and they come in and discuss it. And we put this embedded as part of a course this time. So this was the role of the charter school movement in publicly funded American education. And the students watched the videos ahead of time, came into class for the discussion. And then we used the clickers to gather survey, but they'd already watched both of the videos before we could use those clickers because they'd watched at home. Definitely had more class time devoted to discussion. Success, but it wasn't as good a discussion. And we're not quite sure why. They don't seem to have watched the videos the same way that they did when they were in class. We take some accountability, some responsibility for that. Perhaps we didn't prep them enough. We didn't put the assignment in a context. They didn't know why they were watching them or what they should be watching them for, and they needed to do more upfront prep work. We've heard from other people the same thing, that people don't watch the same stuff the same way at home, and it could just be you're used to the distractions. You're watching on your computer, your email's there, your shopping is there, your life is there. And you don't watch it with the same focus, or some combination of those two. But it definitely was not the same quality of watching, or the same quality of discussion, as when we watched them in class. We also lost ability to gather data during the viewing process, because they've been viewing at home. There's probably a technology that could address this, but we're not that. I mean, you could have questions pop in the middle of the viewing. And this one had kind of the worst feedback. This one was the lowest percentage, only 70%. Felt that the integrated video and discussion was better than either would have been on their own. It was interesting. But we were not deterred. And this time we thought, let's take it even a further step, and let's go all online, fully online. Because this will address the pedagogical challenge of how do you get people access who can't be on campus, who can't be together in the same room? How can you reach a broader audience? So, fully online and flipped. Clearly fully online, they had to watch the videos at home. And We didn't try to do, it was not a MOOC, you'll see in a second. It was a very small group of people who were participating. We ran it a couple of times. There's a picture of us. Here's Kay doing her teaching, right there in the middle. It was a live stream video, 12 to 15 people in a discussion. Here was a hypothetical that we had set out for them to discuss. And here I was trying to take notes using this as a whiteboard, as you might in a case discussion or a bubble discussion that takes place in class. We had people from all over the country at the same time. It's pretty exciting. The discussion was fabulous. I think if we had done it more than once, people would have very quickly forgotten they were not in the same room. It felt very similar to being in a seminar discussion room. The online format, 23% felt it was as effective as in person, 36% said not as effective, and 41% were uncertain. And that's what I'd like to see if this were a whole class, and you had multiple times, you got used to each other online, which direction that 41% would go. And 95% of them liked the integrated video and discussion. They had watched the videos at home, the discussion was better. This was an older group. These were doctoral students who had already graduated, as opposed to the first time around, they were master's students who were currently in the program. That could be why. It was voluntary. The first one was part of a course. And here are two of the testimonies from people who took it, who watched it. This was the online one. And I especially like this one. I still don't think online experience can begin to approximate what you get in person, but if that's not feasible, this is the next best thing, and the trade-off of access. So the lessons learned. Content production is a lot of work. A lot of work. The logistics of finding the people, of getting videographers and interviewers to the people, or getting the people here, transcribing the interviews, editing the interviews, re-editing the interviews. It's a lot of work. So that was one. By the time we're done with the content production, we know it inside out. And so then the question is, it came up the other, somebody else using this content, if you don't know the interviews and you don't know the topic as well as we did by the time we produced it, so what impact does that have on the discussion that you're able to lead in class? We're not sure. But we may find out with the data set. And actually with the one that we piloted that is going to happen this spring, it won't be Kate teaching it, it'll be another professor at the Ed School who teaches about bilingual education. So we'll see how that goes. In terms of the pedagogy, this also got mentioned earlier, it provides some insight into learning styles. We got requests, like, I wish it had been a podcast that I could have listened to as I walked, and not just on the video. Could you separate out the audio from the visual? We gave people, that when people got to class, we gave them the transcript. And there were definitely, I mean, we gave them to them because people call each other on stuff. Like, you tend to, it's like this aha moment when you say, well, so-and-so said da-da-da, and somebody else says, well, I don't see where he say it. And how we've projected, he's the conservative thinker, he must have thought that, and in fact, when you look at the transcript, it's not there. And a transcript is handy for that. You're not going to go back through the whole 20-minute interview. It's much faster to skim a transcript and see whether or not it's there. So those play really well together. The one that we did fully online, the way we did it with a small group, it is not a time saver and it is not a money saver. An incredible amount of upfront logistics to get everybody signed up, get their computers working, get them the first materials, then get them the second materials, get them the survey at the end. When we were actually, and then get all of us in the room and our computers are working and the sound checks. And then in the room, a seminar that Kay could have run with her eyes closed for a 15-person discussion. I was there on the whiteboard, a technologist was there monitoring the chat board in case anybody was having technology problems, and Kay was there. So it took 3 people for a 15-person discussion. Perhaps all worth the greater access that people can have to be in the same room together. But it's a trade-off. We didn't find it a money or time saver. And the live thumbnails worked really well. That people really were present and you could see, and you could see where they were looking. Nobody was getting up to the bathroom because we noticed they weren't there. And it's just more engaging to look at live faces, to look at each other's faces, than to look at still shots. So something we've not experimented with, but we can still go there, is the synchronous versus asynchronous. So all of our examples were synchronous. Everything was happening at the same time. We could try running a discussion asynchronously through a chat board. It's not, we talk about how to keep students engaged at a distance. There's also the factor of the teacher and the professor. And for some professors who really enjoy that face-to-face relationship and contact, the asynchronous doesn't hold quite as much appeal, the same engagement. Or maybe we just need to get better at it. So, to be decided, to be found out. And again, very clearly, each step of the way, we never thought, oh, there's technology, let's use it. It was, oh, what do we want to teach? And how can the technology help us do that? And the HILT spirit of experimentation was a huge help. The idea that we didn't have to succeed, and we were there to sort of have fun with this and play with this and try out different ways, was incredibly freeing and exciting and brought a lot of energy to the work. So we're very thankful for that. And the end result was that we used technology way beyond what we headed into the project with, but just iteratively and incrementally.
Great, thank you, Sarah. So while Jenny is getting set up, any questions for Sara?
Given the high cost of overhead in terms of both time and money in producing this content, to what extent is it feasible for this process to be iterative, whereby student experience going through each of these bundles is then reincorporated into the next version of each one, as opposed to experimenting with different modalities, but trying to improve and refine the original content? And does that become cheaper and easier as you go along?
So it's become, I'm not quite sure I'm understanding that. I'll tell you where we're sort of thinking in terms of that. First, it's become cheap. It's become easier and therefore cheaper as we go along, just because we've got a protocol now. We know how many times we need to contact the interviewers. We know how long we need, how much tape we need to get 15 minutes of good stuff. We know the teaching pedagogy is actually, that's one of the realest strengths, is that you can go through sort of the same questions regardless of the issue. So a lot of it has become more automatic. In terms of making more bundles, our vision, our dream would be that there is sort of a library of bundles that people can go and use, and that we would have a videotape or perhaps also written instruction, since some people like one way or the other, about how to teach with these. So that people could learn about bundles, could choose, oh, I want to talk about immunization and whether or not the state should force immunization or force immunization. And now I'm going to watch this video on how to teach with this, and then I can like sort of click into wherever all these materials, the supporting materials and the tapes are held, and use that. And they're modular, so you can take it out and use it where you want. Does that answer your question at all?
Yes, definitely in terms of sort of ongoing evolution. I was just wondering to what, do you go back and refine the content, whether it's about the teaching delivery or the
teaching delivery, yes. The teaching delivery for sure has been refined as we've done it. To go back in and re-edit it just gets prohibitive. I'm sure somebody else could come to it with fresh eyes and want to do that. We haven't wanted to do that because we're kind of like, we want the excitement too of going on to the next thing. So, but we spend a lot of time in the original editing. They're pretty good. They're pretty good. And would you go out, would you bring in other material that you already have footage, or would you go back and get new footage? You could do that. You could make them better if you went back and got new footage for some of the questions. Yeah.
You mentioned that students didn't always watch the videos and reasons
we don't
for that, and I think that's a recurring theme that you begin to hear with some of the flipped classroom approaches, blended approaches. Have you thought of either some sort of readiness assessment exercise or grading class participation or other things that might ensure that students understand that this is really essential preparation?
I think that with the master's students, it wasn't an issue with the students doctoral students who had already graduated and were coming back to be in a room voluntarily with a professor who they loved. Wasn't an issue with them. With the master's students who did it as part of the course, I think if we had been if we'd given a lot more prep, people are used to what it means to do a reading. How do I read the first sentence of every paragraph? Sometimes there are guiding questions. We didn't do any of that. We said, just watch these videos. And we needed to do more about why we were doing this, what we were going to do with it in class when they came in. Perhaps we could even share the teaching steps ahead of time so they know exactly what we're looking at. First, just what did they say, what are the values, beliefs, and assumptions that underlie what they say, where are the common ground, and they could have that ahead of time. Might help with the quality of the watching. They're not like Peter's, they're not exciting videos. They are interviews of somebody sitting talking. So sort of like a talking head interview with no any flash to them. We could put flash, that might keep people watching.
Okay, thanks, Sarah.
Yeah.
So if you joined us for the keynote earlier at 9, one of the things that you heard Professor Melissa Franklin say, well, in addition to that new word that is actually a physics term that I never knew was a physics term before, was that she made the case for the need for additional assessment of what we are all doing in the blended learning space. And one of the people at the forefront of this effort here at Harvard is Jenny Bergeron from the Derek Bach Center for Teaching and Learning, where she is the Director of Educational Research and Assessment. And Jenny's going to tell you about some work that she's been doing looking at some of our first experiments in the blended approach, particularly using some of the Harvard X resources.
Thank you so much, and thank all of you for sharing such great ideas and approaches in blended learning. So as you saw this morning, we've seen a variety of approaches in terms of implementation. We saw 2 examples where videos were developed and then integrated with brick and mortar courses. We saw the other example where modules were developed in tandem with material and where students were given the opportunity to watch these videos and media content in class or at home. And then all 3 examples, what we saw was that everybody tried to create engaged learning experience through the use of activity-based approaches in the classroom. By engaging students in group discussions, we saw in laboratories by solving problems, using case studies, and by engaging students online, we saw with Professor Galison's course with the use of comic books, displaying artifacts and objects, wearing costumes, doing animations, conducting interviews. We saw a great range of things. So it's really important as we move forward in all this is having great exemplars because it's really important to see what the possibilities are. So what I'd like to do is end this discussion by sharing with you some results of some studies that I conducted last year and some best approaches, some recommendations that we learned from these classes. So last fall, the Bach Center worked with 6 new classes taught in the blended format. 4 of the courses were undergraduate courses. They were originally Gen Ed courses, and they were revised to be blended. And then 2 of the courses were in the School of Public Health. So our main purpose was basically to evaluate implementation. As you all know, it would be too premature to judge impact at this time. And the results of these reports were really to give individual feedback to the faculty and their teaching teams about what was working and what was not working so that they could make improvements for the next iteration. And what we did is we produced these individual feedback reports, but we also produced a large summary report giving recommendations on how faculty should approach these if they're teaching a blended course for the first time. And as part of these studies, we used a variety of approaches. We used surveys, we conducted focus groups, we made in-class observations, and we integrated this with Q evaluation data, which was kind of nice because, like I said, 4 of the courses were previously taught, so it was nice to have some benchmarks. One of the things that we first noticed, as I'm sure all of you noticed today, was the high variability in terms of how faculty were implementing blended approaches. And in particular, what they were doing in the classroom to get students to actively engage. And of course, this varied by class size, the content material, and the actual physical space in the classroom. So I believe that the first round of challenges, as Peter already mentioned, was figuring out what to do with the extra class time now that we've freed up lecture with the videos, and how to engage students. How do we get them to participate? How do we get them to now take responsibility for their own learning now that we are asking them to participate in more active ways? And how does the role of the faculty member change with all of this? Now faculty, they have to serve more as a role as a facilitator rather than the traditional lecture format. So I want to give you basically a quick summary of some of the key findings from the study. Number one is that students really valued the flexibility of the blended format. They love the ability to learn at their own pace. They love the ability to rewind. They love the ability to fast forward. They liked watching at their own time and in their own place. But even though they enjoy the flexibility, they still really valued the personal interaction that they had with their peers and with the professor. In 3 of the 4 undergraduate courses, sections were removed because going through this, we really weren't sure how much extra time this all was going to take, so they decided to do away with sections. But what we found is that students really missed sections. They really wanted opportunities for small group discussions. They really wanted time to get questions and answers. They wanted time for meaningful collaborations with their peers, with the faculty, and a deeper sense of intellectual community in the classroom. We also learned that students really valued the quality of the Harvard X materials. They realized that the faculty had put a lot of effort into these. For the most part, this is very interesting, and this sort of gets back to what Sara was talking about. We found that students roughly spend the same amount of time in the blended format out of class as they did in a traditional Harvard class. This was data collected from institutional research. We find on an average, Harvard students spend between 3 to 6 hours outside of class on average in a typical Harvard class. We found the same thing with the blendeds, to our surprise. One of the reasons why is because we were able to look at watching behavior. And students take shortcuts. They are not watching these videos as we're thinking they're watching the videos. They rewind, they play the videos at accelerated pace, they take shortcuts. So many of them adapted and reported this, and we found it on the online watching behaviors, that they adapt time-saving and efficiency strategies to get through the material, to answer the embedded questions. Right now, we're working with Harvard X researchers to go actually back and look at some of the clip data to validate this, and we are finding indeed that they are adapting time-saving strategies. So this was interesting. The other thing that we found that students, because this is a new experience for them, we found that they often tend to conflate the online or the blended approaches with the actual implementation of the class itself, because they simply don't know, this is most of their first time with blended learning. So they're conflating the blended approaches with a particular course's implementation. So it's important to keep this in mind. The most common student complaint with the online learning was often that in-class activities were redundant with what was going on online, as faculty were trying to experiment with best how to use class time. So we're still trying to figure that out. And as one would expect, the in-class activities work the best when they were well structured, such as when students were given discussion questions in advance, when they were given problem sets or worksheets. So the key findings of this study, we developed a set of recommendations. I think these are important if you're considering blending a class. The first one, pretty intuitive, to begin the planning process early. This is important because just as much time and attention devoted to the development of digital resources really needs to be allocated to developing in-class activities that engage the student learner and trying to find a way to integrate the two, because this is very challenging. And mastery of the traditional lecture format does not necessarily translate into fluency in student-centered approaches. So the flipped learning approach really requires instructors to assume more of a facilitator rather than a directive role in the classroom as they try to transition their students to be more active and more self-directed in their own learning. So it's really important. It takes careful time and careful planning. The next thing is the importance of using intentional design. When designing courses, it's easy to assume just because these approaches are interesting and engaging, that their students are actually learning from them. So a selection of instructional approaches really requires a knowledge of their limitations, their relative strengths and weaknesses, and most importantly, their alignment with the course's instructional objectives. There should be justification of why you're doing things, why you're using videos, why you're using specific course material, because technology might not always be the best answer. The other important thing is making participation and grading transparent. Because this is so new to many of our students, clarifying exactly how to participate, how participation grades are calculated, what type of participation in the class is valued, serves to refocus students' anxieties from the self to more collective responsibility to what they're doing in the classroom. The other important thing is providing clear feedback, and that's what Professor Galison mentioned as well. Again, because this is a new way of participating, it's important that students feel comfortable and understand the course expectations. And feedback helps clarify mistakes, is able to direct student learning. And again, this is particularly important because this is new to them. Managing student expectations is also important. Many students in the study regarded the digital course components as attempts to supplant rather than to supplement in-class activities. So to correct for this misconception, I think it's really important up front that the purpose and relevance of the online format is clear to students. This can be even as easy as at the beginning of the class saying, this is why we're choosing this format above this format. And the interconnectedness of the two. The other important thing that we found in the study is engaging the physical space. A lot of these, or a couple of these classes rather, were really large. They were large lectures, and the classrooms are in amphitheaters, which makes activities-based learning very challenging. So when doing this, there should be really, if we're doing active learning, there should be more activity and activation for the professors as well as the students themselves. We recommend that investigating the classroom before you actually go teaching a blended course. Potentially you want classes that are more modular and less amphitheater-like. This encourages active learning. This is a big one, add and subtract. This is what we saw from Sara. This is what we learned from the study. Failure to redesign an existing course that has been previously taught in either a MOOC or traditional format is a major contributor to excessive workload. We want to avoid adding additional material without subtracting from a course's previous design. Because what we saw is students become overwhelmed and they start adapting time-saving strategies and learn in less than meaningful ways. So this can be as simple as making time commitments clear in the syllabus, highlighting potential learning gains for these new ways of teaching. It can be in the form of shortening videos, reducing the number of video segments. Again, just honestly reflecting on the central learning goals of each lesson and then adjusting the assignments as such. And then publishing the length of video clips so students know how to manage their time. And then the last one is seeking advice from others, like we're doing today. It's really important to consult others who've taught in this approach. Consult teaching and learning centers. The Box Center has developed a BLAST group, which is a blended learning support team that works with faculty on media production, with assessment, with course design. Also, Harvard X has the Faculty Academy where they'll work individually with faculty and you'll actually lead with a work product. So this is another great venue for support. And that's basically it. We maybe wrap up with questions.
So any questions specifically for Jenny or for any of our other panelists? Yes.
I was wondering about standards and sort of production quality and what thoughts go into that as far as guiding faculty when they're developing materials. Because obviously we've seen a variety of production qualities and what role that plays in learning.
Well, I think because these were the first round of courses that, I mean, Peter, you can probably speak more to this. There's really not quality control in terms of production.
In different courses?
Yeah.
No, I think that, I often get asked this, and people, I think that the most important thing is the material that you present. Because I'm a filmmaker, I cared a lot about that, but I don't think that's the main thing. I think the main thing is to really work out what it is you want to do. There's some very good courses at MIT where they're recorded by the professor on their Mac, open it, press record, upload. So there are all sorts of things, and things need to be legible, and I think the interactive aspect of it is important. And if I had to choose between having things where the students are doing something and very high production value of the filmmaking, I would probably choose something that was interestingly interactive. I mean, when I talk to people, web designers, if you have like a game that or you want to do something interactive on the web, they say, spend your money thinking, or your time spending thinking about what the structure of what you want to do is, not using super fancy three-dimensional graphics where you could spend arbitrary amounts of money. I mean, some of the sophisticated game sites can cost tens of millions of dollars. So I think that in miniature, that's what we think. So I would say the most important thing is thinking through what you want to do, get your material organized, figure out blocks that work, things that the students can interact with. But in terms of the actual financial investment in, I think you have to adjust it to your needs.
So I'd say, some of the videos that our students appreciated most were our how to use the Stata program, the software we use to analyze. And a lot of the videos I sat in my apartment at home. I used a software called Camtasia, which allows me to record my computer screen. I talked into a microphone while walking them through how to use Stata. And I scripted out what I wanted to say before it so that I would have an idea of how to do it within 10 minutes maybe. And the students say those are the videos that they want access to when they leave the course. They can refer to it. So really low budget, no high-tech things, but they really appreciated having somebody just walk them through a simple software. So, I don't think it needs to be fancy.
I was curious specifically about the synchronous discussions with students that you talked about as part of some of the learning bundles, because I feel like that is really important to students. In addition to having great videos and other things, like some form of like a cohort where people are interacting with each other, I think really helps that experience. And I don't know, I found I've only done this in one course at the School of Public Health, and I don't know, maybe we haven't found the right technology yet, but it didn't, I felt like one problem was that we had students from all over the world, so there was some problems with internet connection, that was one problem. But even apart from that, sometimes I felt like with more than say, 8 students I would say would be the absolute max, that it seemed like it would work without something major kind of falling through the cracks or something else. So I guess I was curious, sort of a little bit more about the technology. And you made it sound like it all worked perfectly.
It worked really well, and we got up to 15.
Yeah, which is way higher, I think, than we ever did successfully.
We were using Adobe Connect. I don't know what platform you were using.
We've tried a couple different ones, although not that one.
So we were using Adobe Connect, and it was pretty good. And I think now there are several schools and the university who are using Adobe Connect. But yeah, the technology is glitchy. Really
right, because at one point, people were coming in and out, and there were a lot of it. Usually worked. We got through it, but it certainly was far from smooth.
But to your comment about how desperate people are for that kind of interaction, in other work that I do, we did online sessions, and we had breakout rooms using Adobe Connect. So we had 70 people, and then we sent them into breakout sessions of 7 each with a facilitator. And the technology was really glitchy. And some people, you couldn't see their faces, you could only hear their voices, and they stayed in the rooms. Even people who didn't have anything, they would stay in to listen, and they gave good feedback to it. Even though they were in and out, and they were turned, you couldn't see them, and it was still worth it to them to have that contact with colleagues.
I just want to add that we're Charlie Nesson's MOOC for next spring. We're demoing Unhangouts. I don't know if anybody has seen or heard of Unhangouts, but it's a product of the MIT Media Lab, and it's completely free. And it creates a lobby that will host, I think, up to 600 people, and then breakout rooms. And it's video, audio, text. And we just demoed it for the first time yesterday.
What's it called?
Unhangout.
Someone from HILT just gave me a high sign, sorry, that lunch is ready for us upstairs, but.
Just for you to know, yeah, it's built on top of the use of Google Hangouts as the chat.
Well, thanks everybody for coming, and please do continue the conversation. Also down upstairs to lunch, which we get in 2 seconds.